Hi, everybody. Thank you for coming. My name's Erin Schnabel. I work obviously at IBM. It's actually my 20th year there, which is ridiculous. I don't think anybody really normally does that. Do you know anybody else that's worked anywhere for 20 years? Well, right here. You guys may have seen me around. This is going to work now. No, it won't, of course not. See, that's me. So 2017, I did a main stage at SpringOne with Cornelia, and I had to spend this year being told by all of my friends, oh my God, you're on the Spring website. So if you guys have seen me around, that's why. Yeah, that was fun. So we're going to talk about metrics today and how you can use them to understand your application's behavior. But I want to take a step back through some backstory. This is backstory that should at this point be really familiar ground for all of us. So we've been spending, how long now? 5 years? 7 years? Feels like, talking about this whole transition from our big monster monoliths into microservices. As somebody who worked on Component Broker, on WebSphere, on ZOS, I know what the big things look like. I've done my share of things in the guts of those. We're still looking from taking the big pieces, moving them to many, many little pieces, and all of the learning that we had to do. The reason I'm mentioning that is not because I feel like going through it again, but because it has changed the context that application developers are operating in. So we're starting from the case where we have cloud environments. They have dynamic compute. We have flexible capacity, right? We want to change the way we're doing things so we can better take advantage of that environment, right? That's why we did this. So that started requiring, like we did that first, I mean, honestly, everything we needed to know we learned on the mainframe. We've done virtualization workloads since the 70s, okay? Just saying. But as we moved towards VMs and into containers, we got to the place where we want self-healing, autonomous systems that can do their thing by themselves as much as possible, because we figured out that humans are not always fast enough, reliable enough, right? Human error plays a part here. And that means that orchestrators, there are many, we're just gonna start talking about Kubernetes a lot. Orchestrators have started taking on some of the roles that even our old WebSphere systems or Oracle systems used to have, right? They're doing workload balancing, they're doing service discovery, they're doing placement and management of your work throughout your system. And they're bringing on more and more capabilities in order to get your work distributed onto this flexible infrastructure. And the follow-on to that, which is why I went on this whole thing to begin with, is that it means that applications have to become generic entities as far as the orchestrator is concerned. That's why we have containers. That's why they're essentially a box. When you look at the 12 factors, they talk about that clear boundary between what's in your app and what is in everybody else's, right? It's like you're not supposed to necessarily know about each other. They're generic, these apps, they're transient. And I mention these because as Java developers, we're used to, especially from the enterprise environment where those technically and typically were Java application servers. The behavior of the JVM was the center of the universe. And now we're in this case where we are not the center anymore. We are just another animal in the barnyard. Not only that, we're just an animal that looks like all of the other animals in the barnyard. So what we're trying to look at and observe and understand is completely different than it was for us as application developers. Like our expectations and what we should be looking for has changed a lot. So orchestration, orchestrators, right? It requires that your systems are observable. And I'm cracking a bit of a joke here, that a system is observable if you can tell what the hell is going on without having to redeploy everything to add more trace. You should be able to tell from the information that you have where a problem is, right? There's 4 big pillars of observability: health checks, metrics, log entries, distributed trace. Those all do different things. They work together. I've had a couple people say, well, why do you need this if you have this? And the answer is, yes, you need that. They do different things. And again, in this, I'm trying to show the generic infrastructure view from the application view, right? So generic infrastructure dealing with boxes that are all the same. Some of those boxes are going to be really intelligent on the inside, and some of them are going to be dumber than rocks, right? Dumb as a box of rocks, that's what it is, which means the infrastructure has to be defensive. So it's going to have a default behavior to check, to tell if that box of rocks is alive or not. Right? Is it functional or not? It's going to have some default behavior for that. It's going to have default behavior or customized for its purposes behavior to collect metrics about resource utilization. So all the use style metrics. If you're looking at node capacity, all of the memory, CPU utilization, all that stuff, guess who's doing it? Kubernetes is doing it because it wants to make sure the node is healthy. Your app is like your little Java application staring at the threads in the garbage collection. So you're within a little box, and Kubernetes is telling you how big your box is. You're not going to be able to take over the world anymore because Kubernetes will shoot you first. Log collection. Now this is where there's a transparency difference. So you definitely have your infrastructure, be it like a Kubernetes itself or any of the services deployed on your platform, taking the hose pipe, and connecting it to wherever else it needs to go. They're not doing log inspection, but they're helping you with the log aggregation problem. That's typical 12-factor stuff. Don't worry about rolling your logs, just send them out, right? So the infrastructure is helping you, but it's not doing introspection. Now, distributed trace is interesting. I am not going to talk about distributed trace very much, but the interesting part to note for distributed trace is, again, this role of infrastructure coming in. If you know anything about the history of Istio with Envoy, the way I like to think about the origin story of Envoy is Lyft was being defensive with their infrastructure. They provided a mesh, a plane that would ensure all of the boxes had a minimum set of capabilities in them, regardless of whether or not the person doing the stuff inside the box was smart or not. So the mesh always makes sure, for example, in the case of open tracing, that your spans exist. So the spans exist. It will make sure that they exist. They will always be there. Now, from the application space, you've opened the box. You're in the application determining what it does. As Java developers, we're going to write health checks that are smart enough to know when all of our dependencies have been resolved and we're actually ready to roll. That's good for us, and it helps the infrastructure that's smart for us to do it that way. I'm going to talk for the rest of the talk today about things you can do for application-centric metrics. So I'm not going to beat the dead horse here. Well, it's not dead yet, but anyway. For logs, it's interesting. The app is definitely going to be in charge of what's in the logs. Whether it's your applications team decision to have it be JSON or not, or like a big organizational coordinated decision, thou shalt log JSON, whatever. The point is, as an app developer, you know what information it should be in the logs. It's a record of what has happened. You want to record both important events. Your logs are going to contain like the detailed stack traces. You can't really put those efficiently anywhere else. They go off into la la land. The question is, how often are you looking? How often and when are you looking at them? Not whether or not you have them. And again, the applications do still have a role with distributed trace, just to finish the progression here, because it's the applications that know the relationships between the spans. So the mesh can say, well, there's requests coming in, there's requests coming out, and they're going really fast. But the application can say, this request coming in goes with that request going out. And at this point, for Java applications, pick your REST framework, it already does it. It doesn't really matter which one you like. Everybody here probably uses Springs, but there might be some that don't. And they will carry the context for you. So if you're coming in on a thread that has a context, you're going to make an outbound call, it will just propagate the context. And it's like you didn't do it, except that the application totally did. Okay, so when we're looking at what? This is another question I had. That's why I put this in here. Somebody asked me this just yesterday. For health, you're just trying to make sure the service is ready and it's not a zombie. That's when you use health checks. You don't use them really for any other purposes. For metrics, you can ask questions. How often was this called? How often did this happen? If I look at the total, these are all aggregates for analytics and statistical analysis, right? So that's what metrics are for. For logs, you get the detailed, when this was called, this is what happened, or this is what happened before this other one happened, right? You get details. With distributed trace, it's how does this service call fit in the end-to-end flow through my entire system, right? So that's your context-rich, real end-to-end flow. So you're going to use all of them for different reasons at different times. They're not exclusive pieces of your system, right? They're all part of making your system observable. Okay, so that's the end of the backstory. So what I want you to get out of the backstory, aside from Erin talking a lot, is that as an application developer, looking at my box, what's going on in my box, what I want to measure is different than it was before. And some of the metrics that I've traditionally had may not have the same importance all the time. Like from a what am I doing monitoring day to day, the infrastructure is going to be doing a whole lot more management, sanity checking, whatever, for me. So then you start to look at which metrics are important for me to make sure that my application is actually doing what it's supposed to be doing, and so that I can get some kind of alert. You don't necessarily have to go to alerting, but I can get some kind of an idea if things are not going the way they should be going. We're going to use, I have used Prometheus for time series data. I've got Grafana visualizations. I'm using Micrometer. I will show you where I'm using Micrometer. I'm not going to go into detail with every line of code. I can show it to you if you want. We can crack it open. We'll see how fast I talk. So we were using Micrometer to get these metrics in. Monsters. Yeah, monsters. So where this talk came from was Erin being like, no, I need to actually do this stuff myself. And I'm glad I did, because I learned that nobody actually likes writing Prometheus query language. That's what I learned. Because every time I asked for help, nope, I don't know. Nope, I don't know. Nope, I don't know. Nobody actually knows how to write anything in Prometheus. So that was something I learned. And the other thing was I decided I needed to spend more time with my kids. So I'm doing two things. I'm coaching my daughter's soccer team, which is great. And my son is 10, and for some ridiculous reason I don't quite understand, I told him that I would totally be a dungeon master for him and his 5 friends. Bad plan, don't do it. So basically what that means is Erin has had to take everything in her head and put it out and try to get 3 whole volumes of crap into my head so that I can tell these kids what they're doing, and then dump it all out and put what's not working. So what I decided to do was write an app for that. This isn't an app to help me run encounters. This is just an app to help me learn how combat is supposed to work, because I'm supposed to be just knowing how combat is supposed to work, right? I can't be going and looking in the book. So I found, because I was looking for apps that would help me run these combat encounters for my kids, I found all kinds of fun apps, and one of them had an XML document that had like all of the monster manual in it. I'm like, I could do something with that. So I ingested, get 1,000 monsters to play with, give or take a few. And I wrote an app that has 2 endpoints. These are, because I'm a glutton for punishment, this is also pure web flux. There's no Tomcat, because I had to do that just because. And so I have 2 endpoints. Actually, it's because there is a because. It's because I want to hook it up to WebSockets too, and I just don't want to have to rewrite the universe. So there was a reason. I have face-off, which is 2 monsters fighting each other, and I have melee, which is 3 to 5 monsters fighting each other. And they're gonna I get them into like a battle, and they just beat each other bloody until only one is left. So it's a very Highlander model. This is combat rules, this third part. This is the part I needed to understand. First, I have to check first surprise, which is the comparison check on stats, right? I have to make sure, I have to see which monsters surprise which other monsters, and then they get free extra hits of damage. I learned that. See, I learned something. I know now when I sit down with my kids who got surprised. Second thing is they all roll for initiative, and then they go around in that order and again beat each other bloody. So that's great. Each monster has, just like they would, because this is right out of the book, right? They have a type, a size, an armor class, and some amount of hit points. And if you look at the hit points, it has those ridiculous dice notation. Yeah, I had to learn how to read that too. So I totally wrote a parser that would turn those into like normal numbers. So that was pretty fun. Right, so I can read those now. That was a learned thing. And then the weapons have variable damage. And because I had to write the rules, I now know that, when you have the hit dice, you roll to see if you've hit, but you add their hit bonus, and then if it's more than their armor class, see? Mommy can run combat. It's amazing. Look, you're laughing. You're like, yeah, this is what happens when you let moms write code. Numbers. So getting back to metrics, how this is all going to go together. Metrics are all numbers. We're getting to time series, single value, sets of numbers, single measurements. It's actually important that it's univariate, which is the big word for just one number, and not multivariate, because that's a whole different entangled ball of statistical math. And people are just keeping that simple, one value. You'll see almost all time series databases, it's univariate data, and you leave the multivariate data for the specialists. In this case, just for me, really, when I started thinking about all of the questions I wanted to answer, being someone who's been working in this field for a long time, how many times I wanted it to be multiple variables, that actually the one value was really hard for me. I kept wanting to cheat. So just in your head, remember, anytime you want to measure anything, you're coming down to one measurement. And it is a measurement. And again, if you look, we're trying to spot trends, variations. You can do counting, aggregates, the histograms with buckets, right? But it's all forward progression. There's no retroactive editing. That's not allowed. You just keep moving forward. Now with dimensional data, and I kind of hinted at this with dimensional data. So JMX has been around for a long time. JMX is very hierarchical in terms of labeling for where your metrics come from. And the problem is now we're getting into the place where we keep wanting to add more qualifiers. Right? Cluster, like maybe region, cluster, node, and then every time you want to add another thing, well, you've broken everybody downstream who knows there's supposed to be 4 stars, because now there's 5 stars. So your ability to do any kind of math is just completely blown out the window. So when you start getting to dimensional data, what you're saying is, I'm still going to have this one measurement, and I'm just going to use the name that is what it is. I'm not going to have all the prefix qualifiers. I'm going to start adding those qualifiers as tags. And that way I can do querying and grouping and aggregation using those tags later. The important part is that you can accidentally completely blow up the universe if you're not smart about what those tags are. And again, it's really easy to fall into the trap to accidentally do that. I almost did it twice. I had to be like, no, don't do that. I'm like, but I want to get it back to this. That's like, no, but that's an infinite set of values. Don't do that. So you want to stick to things, and this actually shows on the right. I had to clean up my data. So when I was getting ready, before you kick off any long-term monitoring of your application, when you're just trying to figure out what it is you want to measure, you might want to plan what those values should be, and maybe run some stuff and just look at what's showing up. And I can show you the Prometheus endpoint when it's actually running and what it looks like. But I could see, just looking at the endpoint, as it helps, that I'm having random monsters battle each other. So when weird values would show up, it would show, my output would suddenly grow. And it's like, oh, it's because there's claw and claws and bite claw. Well, that doesn't work. So I had to keep bringing down the number of weapons when they were all overlapping, which is a problem no one else but me is going to have in exactly that way. But you are going to want to make sure that you have a finite set of values for your tags. With meter types, there's a few basics, and Micrometer provides them all. So Micrometer is a quite handy library. It's SLF for J for metrics, and it supports these general types of metrics that you have. So you have counters, which are always incrementing, usually by 1, but you could do it by however many, but it's just, you're always going up with a counter. Gauge, gas gauge, speedometer, it's whatever is seen at the time. When it's an implementation kind of perspective, it doesn't have a stored value. When it is sampled, that's when they take the value. So there's nothing that has that value hanging around. It's when you look at it, that's what it is. And then you don't necessarily know what it is ahead of time. Histograms, that's bucketing. So it's when you start taking a distribution of values and you just say, I'm going to simplify these into buckets. And that can be useful when you know you're going to have a bigger set of possible values, right? You can start to chunk them so you can make some reasoned, you can have some understanding what's going on. And then a summary takes those buckets, but also adds a duration aspect to them. And we'll play with those. Although I have to confess, I did not do that much with my application with an actual bucketed histogram. I use distribution summaries quite a bit, and that's because you get for free a count and a total, which lets you do averages. but I didn't do much with the buckets. There's a couple reasons for that, but it just, doing the full histogram wasn't what I needed to do. And in the case of timers, I'm not looking, again, this is my app, I'm not looking at this app from an SLA, you know, fixed response time. Like, I don't have that kind of characteristic where I really needed to dive into that. The support is there, but I didn't go there. So with examples, so from here on out, this is all about monsters and what I tried and what I learned from trying it. I'm trying to, some of what I did was just to try to at least have an example of what using this kind of metric looks like. I have the code, I have stuff running, so I can show you the actual code if you want to see what it actually looks like. But when I'm writing this app, I was looking at things that are interesting to me because of what I'm trying to do, which is why I wrote the app to begin with. When you're looking for your applications, you're going to want to keep an eye on what business purpose you're trying to achieve, to make sure that you understand we're writing the app to satisfy these requirements or to accomplish these goals. So given all of what our application does, what things should we measure to make sure that we are satisfying those requirements or that we're performing well within that requirement? And I can actually show some examples so that it doesn't feel like it's just talk. So one of these, for example, so remember I have face-offs, which is one-on-one, and I have melee, which is 3 to 5 monsters fighting each other. And I have simple counters for those. That's the code snippets, basically, for simple counters. Micrometer works, especially when you have dynamic tags like this, where you don't have to pre-declare everything at the top and then reference them throughout. In a lot of cases, you just say, here's the counter name and whatever tags I want at the time. This is why it's easy to get into that trap, by the way. Here's the tags, here's the tag, here's the metric name, the tags that I want to append, and then I'm going to increment it, and that's how I get my counter. This is why it's really easy to accidentally explode your metrics, because it would be very easy for me to add a tag that has like random arbitrary string value. It would feel very normal for me to do that. It would just have really bad ramifications. In this case, I'm looking to see how many of these battles have been completed. Now, we had this running actually on 2 different rigs for a long time. So that's 6 hours worth of data, I think. But you can see it's 2 real simple metrics at the bottom, right? It's just battles completed total. And I have one, so basically having that tag, face off melee, made 2 measurements, 2 separate numbers. And then when I'm looking in Grafana, which is that thing on the right, I show you the Prometheus queries that Grafana is based on. I can do a rate or I can do an increase. And the increase is saying, they're both saying, what's the rate of change, because you're moving up with this counter all the time. So what's the rate of change within the past X time window? The increase gives you a better scale, basically, on the left. The rate, right, is the rate, and then you multiply it times the number of seconds, and then that way you get a scale that's meaningful to humans. So we're still at over 1,000 battles of face-offs run over the last 10 minutes, and then, or 20 minutes, whatever it was. And then, but you can see the melee is much lower because those take longer, and that'll be reinforced as we look at other metrics, so we can make sure our behavior is the same. I am going a little fast, but that's all right. Monster attacks. So in this case, you have this is why some of what I did was interesting, because monsters can hit or they can miss. Oh, and if they hit at 20, they get double damage, which makes the battle go faster. So I wanted to be able to measure whether or not it hit or miss, right, and whether or not it was critical. And I'm showing that visualization in 2 different ways, right? So the counter is just countering. I'm just incrementing it, just like I did the other one. I'm using increase again for the visualization at the top because, again, it just is a better scale. But you can see I put it in a bar chart on the other one, which just makes it easier to see that the critical hit, the critical miss. I mean, really, like it's about the same odds that you're going to get a 1 or a 20, so you would expect them to be approximately the same. And they are. But you can also see that it's likely they're having much better odds hitting than they are missing, which has something to do with hit modifiers and armor classes, I think, which is good for kids who want to hit monsters because that means they're more likely to hit the monster. That's good to know. Now, survival. This one has interesting getting the data out of this part was somewhat interesting, and I can show you what the raw data looks like. But what I wanted to try to understand was, I have monsters, they're fighting each other. How likely are they to survive, or who survives longest? How many rounds do they last? And in this case, this again, I have two. I have by type and by size. And so I can see sorting like the top 5 surviving monsters. And medium humanoid is the largest. Is medium humanoid the largest because they survive the most, or because they're the largest population group? The answer would be the latter. But if I look at the individual ones, right, I can see from a leaderboard perspective who you don't want to be in battle with, because they will wreck you, because they will survive more than you will. And I can show you what the actual Prometheus data looks for that. But it gets, again, this is two tags, so you get 2 measurements. You get 2 degrees, I guess. So you're times 2. With winning, and again, this is just counters, so it's statistics coming from the counters. But I can again see how many rounds were won. Again, medium humanoids are the most. And then for individuals, I can net that out also. And what I wanted to show actually with both of these, with the individuals, is I did not put the individual statistics, and again, this is a choice that I made. I did not put the individuals, even though that's a bounded set, I did not put it with the other 2. Because that would have been like an order of magnitude ginormous that really didn't have to happen. So that's like a deliberate separation between counters so that you keep the size of metrics that you're dealing with sane. So I don't know how many of you would have picked up on making that kind of a decision when you're just setting up counters, where you might break up your labels so that you don't have a ginormous expanding namespace. That's survival and winning. Now, this is hilarious. I don't know how well you can actually see that green line. I have a middle finger in my chart, and I did not even do it on purpose because you can't go back and retroactively edit. I have no idea how this happened, but it's great. So I can't know ahead of time how long a round is going to take, because it's how many monsters are in the round. So that's from 2 to 5 monsters in the round. They might critically hit. They might critically miss. They could all hit. They could all miss. So I don't know how long it's going to take. All I know is that at that one time, something really hilarious happened, and the round took forever. So it must have been like everybody missed. Everybody missed. Like, I don't know. Somebody breathed on the dice funny. Everybody missed. And so that one battle had a much longer time. And this is why you use this kind of metric to begin with. This is curious behavior. I would not find that scrubbing logs. There's no way for me to grep for that. Now, it could be that the dice are funny, because they're pseudo dice anyway. It could also be that that's a bug. But there's, like me scrubbing logs would never have found that. I just think it's also hilarious. It looks like a big middle finger. The best part is when you get into battles, the middle finger's still there. And I happen to know that weird round happened in a melee battle, which makes sense. You've got more variables. You've got more people rolling, more monsters rolling dice, which means a better chance for things to go kind of all together very wrong. This kind of data, so here you'll see this is with the duration. Was I doing a duration on the last time too? Yes, I'm doing durations on this time too. So you'll start to see I'm getting the seconds, the max, the count, and the sum. And you get these, we'll do some distribution summaries too. But Micrometer will add those automatically. So it's the difference between me just doing a counter and me doing a distribution summary or a timer. I can now compute my own averages, basically, because they always give me the count and the summary, the cumulative summary. So here, I still have a face-off and a melee. So where with the rounds, I had 3 measurements. With battles, I have 6 measurements, because I have a set for face-off and a set for melee. And you can see face-off is, as you might expect from a length of time perspective, it's shorter, fewer participants, it's much more predictable, it's pretty flat. If I zoomed in, there would be more variation, a lot more variation visible on the face-off side, because the 3 to 5, it jiggles more, depending on how many monsters ended up. It is so hard not to say people. Jeez, they're monsters. Anyway, this distribution summary, this is another example. So this, I'm not doing time, not measuring how much. but I'm looking at how many rounds. So it's a different, the end result is the same. Something with more rounds is going to take more time, but in one case I'm literally measuring time, and in the other case I'm just counting how many rounds. So this is done twice. I didn't include the second one. So in this one is the face-off. I'm counting how many face-off rounds there were. And you can see I'm doing one record line at the end, and it has to do with the way I run these battles. So when the battle is finished with all of its rounds, I do some reporting, and I record at that point, battle finished, here's how many rounds there were. And so I have that for both the face-off and the melee. And they're both varying, but you can see the average number of rounds to resolve a face-off between two monsters is around less than 4. It's halfway between 3 and 4. So you're either going to have 3 rounds or 4 rounds most of the time. With a melee, where you have 3 to 5 monsters, you're closer to 6 rounds, you're closer to double, but you might get up to 7, except for that one middle finger where you had, I don't even know how many rounds that was a lot. And I'm also, if the numbers don't all exactly make sense with each other, I was going across 2 different systems to grab whichever thing had the right. So if it's not all the same data, it's 2 sets of data. So don't yell at me if it's not completely consistent. Lethal weapons. So this was the other thing that I wanted to make sure that I could understand. Now, in statistics terms, that's a spaghetti mess. It's a technical term. That's not really, but you can't really infer a lot of information from a chart that's that crowded. There's lots of different weapons. They all have their own attack damage. I'm looking at the average. I thought I put the, I can show you guys if you want the formulas that I used. I have them, I think, on another page. It's basically the same. But what I find interesting about that chart is only the outliers. So what I like about this is, A, it's noisy and it's pretty for a chart. If I was going to do it again, I would probably use a histogram, or a heat map, because most of your damage is within a certain range, so those would all be hot. But what's interesting to me are the outliers, because those are weapons that just did a ridiculous amount of damage, which means if I was going to design the monster to just wreck all of my kids, I'd pick that one. And I also just really like what all of the lethal weapons are, not one of those. I think extract brain is probably the most appropriate for me right now. Disruptive touch, though, probably that could do too. Anyway, so when I got to the end, the way I do this is I have the battle. I start a round. The round goes through every participant, where the participant is a monster that has a set of attacks. Every time they attempt an attack, I'm rolling all of the damage. When that happens, hit, miss, or otherwise, when that happens, then I record information just about that attack. So in this case, the result of an attack goes into 2 measurements. This is one where I'm just comparing the weapons. This is by the weapon name. But I can also compare the attack by the monster. So it's that attack, that hit, gets counted in 2 different ways. It's correlated once to weapons and then another time to monsters. Now, with some of the high damage weapons, it's not obvious what's happening, but like a longsword generally behaves the same regardless of who's holding the longsword. And so the odds just go that way. But in this case, I was looking at size and type across the attack because they bring in their own dynamics. And so you can see like a gargantuan fiend is definitely not what you want to be fighting. And yeah, this is the 2 at the bottom. It's the same basically for the weapons, right? You're comparing rates to get the averages, and then we use the top 5 averages to get your top 5 list. So I did go way fast, but I can show you more stuff. So there's not much about Micrometer in here. Actually, I can show you. I didn't talk all that much about Micrometer itself because it stays out of the way in a lot of cases. Is that what I want to show you? No, that's not what I want to show you. I didn't have to write a lot of code to do this, but I do want to show you. course, I'm not ready to do this because I was only thinking I might. What am I doing? Everybody tell me what I'm doing. This is why I don't like code. Everybody be like, yeah, this is why she doesn't like code. So if I do a battle, no, it's not going to do that on me, is it? It's running. See? You can see it's running away. But is it going to work? Please tell me why it doesn't work. See, this was running too. It's decided it doesn't like me. Oh, it's because it's trying to do HTTPS. Who's doing that? No, that doesn't work either. There, are you going to stay and not mess around with my fingers this time? Okay, I'm giving up on you. I don't understand. No, see, it did it again. Is everybody seeing my creepy thing? I have like, I'm just going to change the thing. It keeps changing its mind on me. It's going to do it again. How much do you want to bet? See? I have a haunted computer. And it's not going to want me to do it. It's not going to let me do anything. So what I have running, how can I do this? I bet you I can do it this way because it's going to be smarter than that. More than one way to kill a cat or something. That's not a very good analogy. If I just do this, yes, that's better. So if I do actuator, and I do Prometheus, this is what it looks like right now. And this is noisy, but you can see, I didn't actually include anything in here about how many rounds survived. I did do survived. But here's like every time, see here, right there. That's something I didn't scrub properly. The type is a short sword versus medium or larger. Like that's not a good metric. This is what happens when you use. There's attack damage, but you can see how many of these there are. So in the case of like this rounds 1 individual, where I have all of these names, if I would have had the rounds 1 by size, like here's the weight survived, where's the other ones that are 1? If I would have tried to take the one that had size and cross that with individual, you'd be at so many pages of data, you wouldn't come out the other end. And there wasn't going to be any value in comparing those. Interestingly, from a micrometer perspective, is that while it gave me my nice metrics with the Prometheus format, all of the data that I'm collecting is also visible with the metrics endpoint, with Spring's metric endpoint itself. I forget how to do this now. Nope, it's not that. Nope, I forget how to do that one. Brain fail. Yeah, it was that, I thought. Things don't work. Yeah, you can all watch me type ridiculously. There, that one worked. I must have typed something wrong. So, but you can see here, it's still got all of this one actually nicely collects. I don't know if you can see this because it's like terrible typing, but it has basically collected all of the possible values in one place because of the way the actuator metrics is working. So even though from the Prometheus standpoint, I'm only seeing them flat, because Micrometer is working with different metric systems underneath, I could use this one to see what my accrued values were. It's like if I was gonna, what I should have done, I can go through and look at this now and figure out which values I need to prune because they're not informative enough and they're making my data set too big, for example. So if I go back to this, oh, which one do I want to show you? I don't know. I have the attacks working. What do you guys want to see? What I did when I wrote this, and I was talking to some people about what I did. I don't know that I necessarily did the exact right thing, but I did it because what I wanted to do is I wanted to be able to play with I wanted to be able to play with what I was measuring without going in 50,000 different places. So when I was writing this, I'm writing the entire app from scratch, flying by the seat of my pants. And so I made one battlemetrics class, battlemetrics, because then if I wanted to change my mind about what I was measuring or what measurements were called or any of that, I could put them all together and just keep myself sane, which saved my bacon many times over the last couple days. So I am creating I have some gauges. They didn't prove very useful, so I didn't bother showing them to you. I don't think I will remove them. But these are where I create the distribution summaries and the timers. I could have used, so one of the things is because I went through Webflux and then took 2 other steps before I got into where the battles were, I'm not using timer annotations. I could, maybe, but I'd have to go back and refigure out how to turn it on so I can use it on an arbitrary method to get the metric that I want. And so what I ended up doing instead was I've created the timer, and then I have, for example, here's where I start the battle, and I'm returning a sample. And when I finish the battle, then I use that sample to stop. So I can, in this case, when I'm finishing the battle, I'm dealing with the fact that there's either a face-off or a melee. And so I'm recording the values in the right place properly, and then you saw how they showed up later. With the rounds, again, it's the same thing. I can start the round, and then this is where I record. I have an attack damage, right? Where I'm recording, okay, an attack happened. Was it successful or fail? Did it work? Was it a hit or a miss? Was there damage? Was the damage, I accrue the damage to the monster, and I accrue the damage to the weapon. And then when I finish the round, I do a lot of other things. Again, it's all measuring. Sometimes the rounds have no participants, and those are only for surprise rounds, because there can be cases where nobody got surprised. And I do actually have metrics. I do measure when people are surprised, when monsters are surprised also, because that's a fun odds calculation to make. And so my friend Ozzy and I have been talking about what we did here, just to kind of go back to where we were. We've been talking a lot about what we would do next with this information. And from our perspective, we want to take this. We have a text-based adventure game that we wrote a long time ago, because old school. And we use that basically to explore concepts like this. And so we're thinking, okay, so if we have this and we know how the monsters behave, can we tweak the behavior to make the battles longer or shorter? Is there, we're using the metrics to try to see if we can make the algorithms better or more interesting. And then we want to take that and hook it up to WebSockets and figure out if we can use that to drive other traffic through our other game, which is a whole other thing, because we now have a source of random content, I guess you might say, because you have monsters that are battling each other. And it's actually a decent amount of completely weird traffic. So we're using the metrics to try to do that. So I'm hoping this was helpful for helping you guys think about how you might use metrics in a different way. I know it's very not businessy. Do you have any questions? Yeah.
So I noticed there are references to the registry.
Yeah. Well, so there's not for me. So this is in proper Spring form. Your meter registry is injected, can be injected. You can configure it in the usual way. You can configure composite registries. Josh actually has a video out where he shows minus Spring Boot magic, like how you set up your own composite registry that needs to talk to several different downstream players. I obviously use Prometheus, but if I wanted to switch tomorrow to use StatsD or any other thing, I could do that and my code wouldn't change at all, which is, I think, pretty nice. So in my mind, if there's a threading issue, it's not my issue. It's the library's issue. It's a good separation of concerns in that case. So yeah, I think there could be, but if you and I are worrying about it, we've gone out of the box, right? Are there any other questions? No, that's what I did. So I feel, no. Anybody here? Oh yeah, no, like seriously, anybody here? Like, it's on Git. Go tell me it sucks. I'm totally down with that. I have no problems. But what I did when I wrote, the reason I wrote my code the way I did, how did I manage to get out? Because this is the problem when you full screen stuff. So this is exactly why I wrote the code the way I did. So you and I apparently think a lot the same. Because what I did was I put all the metrics gorp here. And so I do have one injected bean, battle metrics, and I put it in places, and all I require is that at the beginning or end, I could, in theory, you could envision, if you really wanted to go crazy, doing some injection of that behavior. Although then that gets, I don't know, I get on the line of, if you just do things automatically all the time, do you do it too much, right? But so as a coder, I'm okay saying, well, these are major events. So whenever I have a major event, I'm going to call something on the battle metrics class, and I'm going to give it the two things. Here's what happened. But that means this is where all that gorp to figure out which measurement, because I feel you, right? I didn't want to, that's why I wrote it that way. Like if I changed my mind, I didn't want to go change. Like, well, now that's an interesting question on its own, right? Whether or not your job is observability. Because I would argue that it is whether you want it to be or not. Because that's what I learned. I learned even, and I couldn't show you actually when I was catching errors, because when I first got 1,000 entries, like XML goes, phew, my log is like 80 million lines long. I had random null pointer exceptions showing up sometimes that I didn't know about until I turned metrics on. I was like, oh, hey, I have exceptions somewhere. But then I knew to go look for them, and that was fine, right? But this was really stupid easy. And it found things that I didn't know. Like I went through the other metrics just, again, to help me learn. For me, I know a lot of this may have been boring to you, but like the odds that my pseudo randomness is generating are still matching what would happen in combat. I'm still seeing this is approximately how often critical hits or misses will occur, even if my kids are rolling the dice instead of a machine. It's a rough approximation. Yeah.
Was there value concern about those strings, the magic strings?
Probably. So if I was going to do this for real, instead of for pretend, or fly by the seat of my pants, those would probably be constants somewhere, right? I mean, it's just, that's a code tidy thing. But I would, there's something I didn't, I don't have it handy. But in the micrometer configuration, there are filters also for those of you that are, I think for me, it's a team size question. But there's a way to augment a registry with a filter that just doesn't let certain values go out anymore, which can be just a real easy way to just say, okay, I had all those metrics, they're spread all over my code, but I just don't want them to go anywhere anymore. I'm just gonna take the spigot, turn it off.
Based on your experience, how hard do you think it is to add things to that? Like if you already have it out?
That's a good question. If you did it this way, it wouldn't be bad. Right, because for me it would be like, what do I want to measure? I don't know that I would go with any, well no, that's a super interesting question. So if I turn micrometer on with any Spring application, now I didn't do a lot of HTTP analysis because that's really not what I'm interested in with this app. But Spring already with the REST template, and there's some other talks today that will go through that, or this week, whatever, that go through the details of what the REST template captures. So just putting the micrometer support in your app, you get a whole bunch of really nice metrics around HTTP workflows, and you didn't have to do anything. So you can get a whole lot of value if you're focused mostly on HTTP workflow or transactional behavior. Those are all instrumented for you. So I didn't want to go there I didn't want to go there, because for me, it's like, why should you write something that's custom for you, right? And I learned all kinds of good things by trying to write something that was custom to this crazy idea that I had. But from adding it to the existing, if you just are looking for HTTP or database performance or any of that stuff, just turning it on, right? And then I would say, be deliberate about what other probe points that you want. And I would do it this way rather than spreading stuff around, but that's Erin's opinion. Anybody else? I'm sorry, I keep talking over here. Hi, everybody over there. Do you guys have any questions? Yeah. 5E. We are doing 5E because I had no idea. Like, I have no history, so I'm like, why would I start with all the confusing things? We're just going to start with the thing that's supposed to be the holy grail of everything coming together. That was my reasoning. But I went a little crazy. I've got like 3 books, plus the starter kit, plus the essentials kit, plus the cards. But it's okay. And so like tomorrow, I'm leaving tomorrow night. Do you know why? Because Friday night, all the kids are coming to my house. And it is bedlam, let me tell you. I keep getting confused if it's 6 10-year-olds or 10 6-year-olds, because the volume level is really about the same. It's kind of crazy. Is there anything else? Oh, yeah, I can. You guys are going to go play. That's awesome. Yes, I get very excited, and I'm totally happy for everybody to tell me my code is crap. I'm down with that. I've got no problems. Oh, look, see, that's what a JVM gauge looks like. I got that one for free. I had a hard time writing gauges for my app. I didn't find any that were useful, but it's very easy to have a gauge, and Micrometer supplies you with several gauges. A lot of them are tied to their JVM behavior. So, who's going to go look at my code and tell me it's horrible? You guys, when you go look at the dice class and be like, what the hell did she do? It was fun to parse 1D, 14D8 plus 3D4 plus 26. Regex for the win. It's awesome. Metrics for the win, regex for the win. All right, so I think we're good. Unless anybody else has anything else. Okay.